Welcome to Physical Science. This lesson is dealing with light and color. These are the objectives that we're covering in the unit. These are the goals for today: to understand how light interacts with different objects and be able to define opaque, transparent, and translucent. So when we talk about light, light can, as light strikes an object, the light can do one of three things. It can be reflected, it can be transmitted, or it can be absorbed. Okay? When we talk about transparent, most of the light that strikes that particular object will pass right through without being scattered. Glass is sometimes a really good example of transparent. Water, air are all transparent materials. When we talk about translucent, as light passes through a translucent object, light will scatter. And usually you can see something behind that translucent object, but sometimes the details are blurred. So if you think about like wax paper or even tissue paper, those would be good examples of translucent type of objects. Opaque materials reflects or will absorb all of the light that strikes it. You can't see through opaque materials because the light doesn't pass through. So you're looking at like a solid colored cup, wood, things like that, some woven fabric. Um, all of those would be examples of opaque materials. So again, when we talk about opaque objects, okay, the color of that opaque object will depend on the wavelength of light that the object will reflect. All opaque objects absorb some wavelengths of light and will reflect others. So when we look at an opaque object, the color of that object is the color of the light that it's reflecting. Okay, so when we look at an apple, the apple looks red because it's absorbing all of the colors except for red, and red is being reflected back to you. The color of the leaves are green because all other colors of light are being absorbed and green is being reflected back. When we talk about transparent or translucent objects, remember that a lot of the light will pass through those objects, okay? And when you use your filter, and I would encourage you to continue to use your filter, or that color paddle, you can put that color paddle, the light passes through that color paddle, and what'll happen is that the color of that transparent or translucent object, so the color of that color paddle is the color of the light that's being transmitted. So if it's red, that'll be the color of light that's being transmitted. So what you're really creating is a color filter by using those different color paddles. Okay, so bananas look yellow because bananas are absorbing all of the colors except for the color yellow, and it's reflecting yellow back to you. So here is an example of using those color filters, either a transparent or a translucent filter. If you were to put red on a red apple, okay, the red light is being transmitted, red light is still being reflected back to your eyes. The green cannot be reflected back because you're blocking it with the red filter. So the leaves look black because it's trying to reflect back that red light. If you used a green filter, the red apple is going to look black because green's being transmitted to the apple. It's trying to reflect the red light back and it can't. But the green is being reflected back, so the leaves still look green. If you were to use a blue filter, everything's going to look black because the red can't be reflected back and the green can't be reflected back, the blue is being reflected onto that object. So when we talk about primary colors, okay, um, pigments are different than um, light. Okay, so when we talk about pigments, we're talking about paints, we're talking about ink. Okay, the primary colors for pigment are magenta, cyan, and yellow. The um, the primary colors for light are blue, red, and green. And we're going to take a look at both of these here in just a second, but they're different, okay? So light primary colors are red, green, and blue. The primary colors for pigment, magenta, cyan, and yellow. Okay, so we talked about that there are primary colors of light and there are primary colors of pigment. So let's take a look at the primary colors of light first. So we know that that light's made up of different colors through the spectrum. The primary colors of light include blue, red, and green. Okay, so light bulbs, sunlight, computer monitors use these primary colors. Okay, when we talk about light, when we have the absence of light, the color is black, right? So like when you turn out all the lights and it's totally dark, like if you were in a cave or in your basement, the absence of light is black. As you add color in, okay, the color becomes lighter. Therefore, black is the absence of color, and when all of the colors of light come together, it's white, okay? So when we mix these different colors of light, we can get different colors, okay? Primary colors of pigment are different, okay? We're talking about using ink, paints, things like that. Okay, when we talk about primary colors of pigments, magenta, yellow, and cyan are those main colors, those primary colors of pigments. When you have absence of color, so like if you just, like, you're not painting or you're not using your inkjet printer, the absence of color, of pigment colors, is white. Okay? As you put all of those colors together, you get black. So it's the opposite. So light, absence of light is black. All of the colors pulled together make white. When you talk about pigments, then we're talking about the absence of pigment colors is white. And when you put all the pigment colors together, you get black. So here's this graphic again when we talk about the primary colors of pigments, magenta, yellow, cyan. When you mix the different colors together, you get different colors. So like you can mix magenta and yellow together and get red, yellow and cyan and you get green. Okay, magenta and cyan, you get blue. When you mix all of the colors together, you get black. And remember, pigment colors are totally different than light colors. So, when we talk about primary colors of light, okay, it's what our eyes perceive because of the light. No matter how an object is constructed, either with primary colors or of light or primary colors of pigment, our eyes perceive it using primary colors of light. Okay, so no matter what it is, if it's something that's painted or whatever the case may be, however the light hits that object and bounces back to our eyes, it'll give us the message as to what color it is. So light will reflect off of an object, come to our eyes interpret the message with the cones that are in the back of our eyes, sends a message to our brain, and our brain interprets it, and we look at it and we say that is pink or that is blue. Okay? Remember that when we talk about black in terms of pigments, all the colors are absorbed, or if we're talking about black in terms of light, no color is reflected back because there's no light, okay? White is when all of the light comes together and forms white, and when there is absence of pigment colors, there is no color. So one thing I want you to think about after you're done watching the recording is, can light lie? How can light lie? Think about what we've talked about today in terms of light color being reflected, absorbed, um, or transmitted. Think about the different types of materials, whether it's an opaque material, a translucent material, or a transparent material. Think about how light comes together to form different colors, how the absence of light forms the color black. But think about it. Can light lie? Hmm.